So for this problem from 5 on homework 4, we're kind of asked a tricky question. We're given this sort of scenario with the ball swinging around like a tethered ball pool, and we're told at what speed is tension the same in both cables. It's kind of weird, right? So the hardest part about this is just sort of like the application, right? We know the basics of centripetal acceleration. We know the basics of net force expressions, and we're just sort of pressed to combine them together now. Remembering that centripetal acceleration is v squared over r, and the, let's see, so we have the F equals ma, or we can say AC, and we kind of pair that with the centripetal force will generate some sort of acceleration. So we can sort of say net force or FC, centripetal force. I usually will write net force is just mass times A sub c. We know our net force is supposed to point in this direction, directly to the left. So let's look at our ball. We have two forces acting on it for tension, and we're going to call this T and T, because remember, tension is supposed to be the same in both cables, so we're going to give them the same tension value. And then we have, well, mass times gravity, mg. And let's see, so this, if we were to draw a triangle, gives us 30 degrees. And this one is 30 degrees. So, well, our net force in the x direction is equal to MAC. And our net force in the y direction is equal to, well, there's no acceleration in the y direction, so it's going to be 0. And so we end up with, well, let's look at our x. We have t times sine of 30 plus, that's for this force, sine gives us that x component. For our bottom tension, we want cosine 30 plus t cosine 30. And now this is where it can get a little confusing because we don't normally have like two t's. It should normally be like t1 and t2 kind of thing. And so it can be a little bit tricky. It can be a little mentally confusing. You might get tripped up by that. But just remember, we need to have two components in that negative x direction. Now, why did we make these positive and not negative? Well, kind of looking at, we're almost looking for a magnitude. Centripetal acceleration is constantly changing directions, and so we don't normally give it a negative or a positive sign. Normally, centripetal acceleration is just a magnitude. And that kind of means, well, we just want to find the magnitude of the force. We don't really care if this is a negative, we'll just get a negative acceleration, which is fine. You know, we're not going to get mad over that. But in reality, we can just look at that as positive and just find a positive acceleration. It just makes things a little easier to avoid negatives. And we can change AC into v squared over r. So you get mv squared over r. And look at that. That's our first net force in the x direction expression. Well, y, we also have, let's see, t cosine 30 plus t sine 30 is equal to mg, right? The two upwards forces are equal to the downward force. They must be equal so that our net force, points to the left. So our y is 0, and so we can create this equality. And let's think about this problem. What do we know? We don't know what tension is. That's an unknown variable. We don't know what the velocity is, and we don't know what the radius of the circle is. We do know 30 degrees, we know mass, we know gravity, but this is 3 variables. And remember, 3 variables require 3 equations. We only have 2. So we have to figure out, are one of these variables, can we solve it some other way? Oh yeah, we can actually solve this r. R is this distance from the ball to the pole. And so you can use geometry based on this 1 meter spacing to solve for r, right? So we have this big triangle, and the key is to split it into two back-to-back right triangles. This is 30 degrees. This is 1 meter. We can find this sort of side by using, well, cosine 30 equals adjacent, equals x over 1. So it's just cosine 30. And that's just root 3 over 2. So that portion of the triangle is root 3 over 2. And, well, let's think about this. This angle is 60 degrees. And this angle is 60 degrees. So this angle right here must also be 60. And now we have to find the angles in the second triangle. We can find our opposite side because we can find x here, right? Call that y actually. So y is just sine, oops, my bad. We're gonna try and find some sort of connection between these two triangles. Right now we only have 3 angles, and that's not enough information to solve the triangle. So the one thing we have that links them is this y side. We can use sine of 30 this time. It's opposite y over 1. And that tells us that y is 1/2. And using y equals 1/2, now we can go ahead and solve for this adjacent side. Tangent 30 equals opposite 1/2 over adjacent. We call this z. And we can find that z is 0.866. There is a square root expression for it. We're just not gonna go through the trouble of figuring out what it is. And we know that, well, where's our radius? What are we looking for, right? We found this distance, right? But that wasn't exactly what we were looking for. The last thing we really want to find is this side length. And so we can use sine 30 equals opposite y, 1/2, over hypotenuse. And we know the hypotenuse here is also going to be 1, right? It works out pretty nicely that ends up being 1. We can call this I accidentally put the 1 there. I got a little bit ahead of myself. We're just going to assign this like a letter, like B kind of thing, like just some random side length. And when we solve for B, we find that it's just a length of 1. So now we're going to look at this base of this shape, right? This is a lot of geometry. We have to move through like 3 triangles. And so it can be a little bit overwhelming. But this is side length B, 60 degrees. We've gotten down to this is the radius. We're so close, we're right there. All we have to do, sine 60 equals opposite r over 1. It's just sine 60. Root 3 over 2. R equals root 3 over 2. Right, so you just have to go through the geometry. There's different ways to do it. I kind of took a couple paths that ended up not being right. You will often have to solve completely all 3 triangles to figure out what you need. And when you get a little bit more versed in it, you can just fly straight to the final answer you need. But we have our r. And so when we go back to our expressions, now we realize we have just 2 variables. We have t and v, right? So how do we solve? How do we get v equals? Because remember, the question was, what is the speed of the ball? And so we need to get a v equals. Well, we want to cancel out t now. So we go over to our other equation, and we say, let's try and find a t equals. So we can factor the t out of the left side. Okay, cosine 30 plus sine 30 equals mg, and divide both sides by cosine 30 plus sine 30. T equals mg over cosine 30 plus sine 30. And now we can take that tension, plug it into this expression up here. And let's just move a little ways down. We get mg cosine 30 plus sine 30. And remember, this can actually be solved for as like a number too. We know what mass and gravity are. So we don't have to keep writing the whole expression each time. I will continue to just for convenience. And then we have sine 30 plus cosine 30. All I did there was factor the t out front. You can kind of think of it as t sine, same as we did before. Right? And that way I only have to write the t expression one time. And you'll notice you are both dividing by and multiplying by sine 30 plus cosine 30. And so that cancels out. And you end up with mg equals mv squared over r. mg equals mv squared over r. And the final step is to find v equals. So we have multiplying both sides by r, mv squared. Well, mass will cancel. So we get v equals the square root of r times g. And this is just the general sort of final expression that you can hope to come to. Whoops, let me grab that. And plugging in our radius that we calculated and gravity will give us a specific velocity that the ball has to travel at. The tension will be constant in both ropes. And of course, it goes back and says, well, what's tension? Well, remember this expression for tension we found? Tension equals mg divided by cosine 30 plus sine 30. Well, you just go back and plug in your mass and gravity and get t equals. That's all it is. All right, and that answers both parts of this question.